One of the most powerful use cases unlocked by hooks is the ability to dynamically adjust the swap fees, allowing the pools to adapt to market conditions in real time. Hi everyone, I'm Sebastian Perez and welcome back to this series where you will learn how to build efficient hooks using Uniswap Hooks Contracts Library. In this video, we'll see 3 specialized hooks designed for managing fees in Uniswap v4. The BaseDynamicFee that manually adjusts the fee at any time after the pool was initialized. The BaseOverrideFee hook that sets the fees just before executing the swap and enabling tailored fees for individual swaps. And the dynamicAfterFee hook that adjusts the fees after executing the swap, setting the fees based on the swap result. These hooks simplify the implementation of dynamic fee strategies, empowering you to customize your pools to align to specific use cases and market conditions. Let's get started and explore the world of the dynamic fees. If this is your first time using Uniswap hooks, I recommend watching our video on how to build a hook using the base hook contract. You will find the link below in the description. Now, let's explore the first case, which is manually setting the fee. And for this, we'll use the BaseDynamicFee contract. Using this contract is straightforward. You need to inherit and override 2 functions. The first one is the constructor, and it's the same override that we used, for example, for the base hook. And the other function is the getFee, where we are going to define the fee amount that will be used, for example, in the pool initialization. This amount is denominated in 0.000%. So if the function returns 10,000, it represents 1% fee. This fee will be set during the initialization, but you can update the fee setting a new value to the contract variable and then call to the poke function. This function allows you to set the updated fee by passing the pool key as an argument, and you can use the same that is actually received as a parameter in the hook function. To make this all work, there are 2 conditions that have to be set when defining the pool using the pool manager contract. The first one is that our hook contract address is included in the hooks attribute, and the other condition is to set the dynamic fee flag to indicate that we are going to use dynamic fees. You can find an example in the test cases for the BaseDynamicFee contract. Let's explore the second case, overriding the fee before a swap. This approach is particularly useful when you need to adjust the fee dynamically for each individual swap based on custom logic. We'll use the BaseOverrideFee contract, which enables pre-swap fee adjustments. It works similarly to the BaseDynamicFee, since it includes a getFee function that you can override. However, its arguments are different. Unlike the BaseDynamicFee contract, this fee is set before each swap and not during the pool initialization, enabling different fees for each transaction. If you want to use a specific swap logic to determine the fee, you'll need to override the before swap function and add there your custom logic. For example, this code applies a double fee or a half fee depending on whether the current block number is even or odd. This approach is ideal for optimizing fees on a per swap basis, ensuring your pool remains competitive while mitigating risk like impermanent loss or volatility. Now that we explored fee overrides, let's move on to the final approach, adjusting fees based on the swap result. For this scenario, we are going to use the BaseDynamicAfterFee hook, which is specifically designed to adjust the fees based on deltas. Unlike the previous cases, these fees charged after the swap was executed. The inherited contract is simpler because the only function that needs to be overridden is the constructor. But to make this work, a target delta related to the pool ID must be set. Since this is embedded mapping in the base hook, a setter must be included in the inherited contract. So the hook compares the resulting delta from the swap with the preset target delta, and any excess from this comparison is donated as fee. There are a few key points to keep in mind. This hook only supports exact input swaps, and for exact output swaps, the hook doesn't apply the target delta. The target delta must be defined before the after swap function is called. If it is not defined, the hook will take no action, and you have to consider that when the operation is complete, the target delta is reset. So for subsequent operations, you have to define a new target delta. The BaseDynamicAfterFee hook ensures that the fees are collected dynamically based on the swap results. And that wraps up our guide on dynamic fee management using Uniswap Hooks Contracts Library. In this video, we explored 3 powerful approaches to setting dynamic fees, each offering unique benefits to optimize the pool responsiveness to market changes. Which approach did you find the most interesting? Let me know in the comments below. If you found this guide helpful, don't forget to like the video, subscribe to the channel, and hit the notification bell so you'll be the first to catch the next episode. In our upcoming video, we'll dive into building custom accounting hooks. Thanks for watching, and I'll see you in the next video.